Lower carbon cement. Today, 4 billion tons of cement, a key component of concrete, are produced every year in a process that requires the burning of fossil fuels. This accounts for around 8% of global CO2 emissions. As urbanization increases over the next 30 years, this figure is set to rise to 5 billion tons. Researchers and startups are working on lower carbon approaches, including tweaking the balance of ingredients used in the process, employing carbon capture and storage technology to remove emission, and taking cement out of concrete altogether. Importance of lower carbon cement. Carbon emission reduction up to 75% in comparison to conventional product, accelerated early strength, improved durability due to formation of nano CaCO3 crystals, low cement and low embodied energy. Steam can be replaced by carbon dioxide. Application of lower carbon cement. In addition to embodied carbon and operational carbon, designers need to consider the total whole life carbon. Whole life carbon emission are most holistic measure of the total impact of our built environment and can help to avoid unintended consequences of focusing on embodied or operational carbon alone. The reason it is not referred to more is that it is more complicated to measure than embodied and operational carbon. A, a methodology for determining whole life carbon is set out in EN 15978 2011 Sustainability of Construction Works, and at a product level the consistence measure for EPDS is EN 15804. To assist with whole life assessment and design of concrete building, the Concrete Center has published a guide entitled Whole Life Carbon and Buildings, which set out the specific qualities of concrete construction that can be used to help minimize carbon impact, including operational energy, using the thermal mass provided by concrete to lower operational emissions. Designing for long life. The longevity of concrete allow a building's useful life to be extended, a key tenet of whole life thinking and a circular economy. Reuse and adaptability. Reducing whole life CO2 through the ability to reuse concrete structure. End of life. The absorption of CO2 into concrete through the natural process of carbonation.